ABCD is a parallelogram such that AB equals twice AD. Now, I'll put a mark on AD and I'll put 2 marks on AB. Now, normally 2 marks indicate that AB has a different length from AD. AB doesn't necessarily have to be twice the length of AD, but in this case AB is twice the length of AD. E is the midpoint of DC. Prove that the line AE bisects angle DAB. Well, here's angle DAB. So DA is one arm of the angle and AB is the other arm of the angle. And the corner of the angle is the letter in the middle of these 3 letters here, using this notation. So if we want to prove that AE bisects this angle, we have to prove that this angle equals this angle. We have to prove that angle DAE equals angle EAB. Now, I won't use this notation in the proof, it's just far too cumbersome. I'll just call the angles by capital letters. So I'll call this angle here X, and I'll call this angle Y. So I'll restate the question like this. We want to prove that X equals Y. This is much easier to write down. Now we're given that E is the midpoint of DC, but DC has the same length as AB, and the reason they're equal is because they're opposite sides of a parallelogram. So AB is equal to DC, but since E is in the middle of it, we can see that the distance of D to E is half the distance of A to B, and the distance of E to C is half the distance of A to B. So in this case the single dash indicates that DE is actually half the length of AB. So here I'm just stating that AB is twice AD, well that's a given, and AB is also twice DE, well that's another given. So these two, twice AD and twice DE, are equal to the same thing. So they must be equal to each other. So we can conclude from this that AD equals DE. Well, twice AD equals twice DE, but of course if we divide by 2 we see that AD must equal DE. Because if 2 things are equal to the same thing, then they're obviously equal to each other. So now we see that if these 2 lengths are the same, then this triangle, that is triangle ADE, is an isosceles triangle. And if it's an isosceles triangle, then 2 sides of it are the same. The 2 sides that are the same are opposite the 2 equal angles. So these 2 sides are opposite these 2 angles. So these 2 angles must be the same. I'm calling this angle M. So X must equal M. But we also see that we have a pair of alternate angles, or Z angles here. M and Y are alternate angles. So remember, we have this Z shape formed between 2 parallel lines, because this line is parallel to this line. So we have that X equals M and that M equals Y. So X equals M and M equals Y. So obviously X equals Y. And that's what we had to show. We had to show that these 2 angles are the same. So M is equal to X and M is equal to Y. So both X and Y are equal to the same thing, namely M, so they must be equal to each other. Now if you want to, you can conclude by going back to the other notation. You can conclude by saying X equals Y, which means that angle DAE equals angle EAB. Part 2. Prove that angle AEB equals 90 degrees. So I'll give that a name. I won't write AEB. I'll call it X. AEB is this angle in here. So you see one arm of the angle is AE and the other arm is EB. E is the letter in the middle of these 3 letters. So that's the vertex or corner of the angle. Now, since we've established from part 1 that these 3 angles are the same, I will give them the same letter. I will call them Y. So these 3 angles are the same. Now, we know that opposite sides of a parallelogram are equal. So the distance of A to D equals the distance of B to C. But we also know by construction that the distance of D to E equals the distance of E to C. And we showed in part 1 that these 3 distances are the same. So now we have that these four distances are the same. So we have this isosceles triangle in here. So I haven't mentioned here that opposite sides are equal. Well, you know, that's probably okay to leave out, as long as we state that we have an isosceles triangle here, and these two angles are opposite the equal sides of this isosceles triangle. So L is opposite this side and N is opposite this side here. So these are the angles that are opposite equal sides. So these angles are the equal angles in the isosceles triangle. Now, opposite angles of a parallelogram are equal. So this angle up here and this angle are opposite angles. So this angle is y plus y, which is 2y. So this angle here must also be 2y. This angle here is angle BCE, or you can call it BCD, or you could call it A. Well, actually you can't call it A. You can call it BCE or ECB or BCD. Now we want to show that x is 90 degrees. Now these three angles here add up to 180 degrees because they form a straight line. Or the angle that they form is called a straight angle. But we also have three angles in this triangle summing to 180 degrees. That's L plus 2y plus N equals 180 degrees. So these are the angles in a triangle. But of course we know that L is equal to N. So I can replace this N up here with the letter L, because we have an isosceles triangle, we have it from here. So we get L plus L, which is 2L. So I'll just write in the letter L here instead of N, because we've established that these two angles are the same. So these three angles, L plus 2y, give 180 degrees. So I can write L for this. But L plus L is just 2L. So 2L plus 2y is 180. Divide this across by 2 and we see that L plus y is 90 degrees. So L plus y here give us 90 degrees. But of course these three angles add up to 180. But if L and y add up to 90, then x must be 90, because 90 plus 90 gives us 180. So just to be clear, I've written it down again. And we take this equation, replace the y plus the L with 90 degrees. So we get 90 plus x equals 180. So capital X here. And from that we just subtract 90 degrees on both sides. We end up proving that x is 90 degrees. And if you want, you can rewrite x as angle AEB.